Geom4.4, we're proving that lines are parallel. These four things right here are converses of the postulate and theorems we looked at in the last section. So if you know any one of these four things, then you know that the lines are parallel. So if your corresponding angles are congruent, the lines need to be parallel. If the alternate interior angles are congruent, the lines are parallel. If the alternate exterior angles are congruent, the lines are parallel. Here's the different one. If your consecutive interior angles are supplementary, that makes lines parallel as well. So we're going to look at these first three examples. We're going to look at number 2 first. In number 2, they're pointing where they want these angle measures to go. So we're talking about this angle right here and this angle right here. And these are alternate interior angles. So I made congruent angle arcs there because alternate interior angles need to be the same if you want the lines to be parallel. So it's really important to identify your angle pairs first, alternate interior angles, then write an equation. If you want the lines to be parallel, these need to be the same. So 3x minus 50 equals 2x minus 5. And what you're going to do is solve for x. So we'll subtract 2x from both sides. Then we're going to add 50. If x is 45, then these two lines are parallel. If x is anything different, they will not be parallel. That's how all the problems in this section work. It's just like last section, but it's the converse. Number 3, these lines aren't marked parallel, but you want them to be. What kind of angles are these? These are consecutive interior angles. If you don't remember, you can look up here. Consecutive interior angles need to be supplementary. So make sure you adjust your equation accordingly. They're not going to be the same. They're going to add to 180. And you don't know what either of them are. So this is where algebra is really important. 6x plus 12 and 2x. They're not equal. You need to add them. And together they add up to 180. That's where your equation is different. That's why I wanted to make sure we did this one. Combine your like terms on the left. You have a 6x and a 2x. Subtract 12 from both sides. And then divide by 8. How many times is 8 go into 168? 21 times. If x is 21, these lines will be parallel. If x is anything different, they will not be parallel. Okay, we're going to sneak back over to number 1. In number 1, you want these lines to be parallel. Well, that angle is 110, and this angle, we don't know. And the other thing we don't know is the relationship that those angles have. We don't study them. They're not corresponding. They're not alternate interior, alternate exterior, consecutive interior. But what you do know, if you want these lines to be parallel, and that angle is 110, then its alternate exterior angle needs to be 110. And if that's 110, now you know that guy right there has to be 70. Because they add up to 180. So in these last two, we identified an angle relationship which we didn't have here. But you can still figure out if they are the same or if they add to 180. Those are your only two options. Are they the same, or do they add the 180? Okay, so I'll sneak it up here. 4x plus 10 equals 70. Subtract 10 from both sides, so 4x equals 60. Then divide by 4. X equals 15. If x is 15, then those lines are parallel. Otherwise, they're not parallel. Come down here and look at number 7. In number 7, they give you a different diagram. So it's down here. It's got 4 lines. Given the following information, determine which lines, if any, are parallel. State the postulate or theorem that justifies your answer. Okay, so the postulate is the one about the corresponding angles, and the theorems are the other three. Angle 1 is congruent to angle 8. If you know that, does that prove anything? Well, I'll cover up a line here to help you. Angle 1 and angle 8, if they're congruent, those are alternate exterior angles. So I'm going to make note of that. If they're congruent, the lines that make them are parallel. So look at the lines that make them. It's this one and this one. That's the transversal. So the two lines, line C and line D, are parallel. That's the converse of the alternate exterior angle theorem. That's what we write there. Converse of the alternate exterior angle theorem. Number 9. The measure of angle 7 plus the measure of angle 13 equals 180. So if that's true, here's 7, here's 13. If I cover up that other line, look at angle 7 and angle 13. They're consecutive interior angles. That's important. If they're supplementary, then the lines that make them are parallel. So that's these two right here. And I kind of covered up the names of them, but it's line E and line F. They're parallel because of the converse of the consecutive interior angle theorem.